Now I'm just going to run through the solutions of the final set of questions that I gave you to do the last day on using logs and indices with real life situations. And I asked you to take a look at questions 1, 2, 4 and 6, and I'm going to go through the solutions now with you. So make sure you have them done before you check out the solutions, obviously, to make sure you can do them, because some of these questions will be on the exam on Thursday. Okay, question 1. A population of bacteria grows exponentially according to the model p equals 16e to the power of 0.1144 t, where t is measured in minutes. What is the size of the population at time t equals 0? Now again, I just want to take a minute to talk about t equals 0. What exactly does that mean? T equals 0 always means the beginning of something. Okay, so what is the size of the population? So you're looking for the value at p equals 600 e to the 0.1144 t. Okay, so that's the formula we're dealing with. Now here we're told straight away in part 1, t is equal to 0. So at t equals 0, which is the beginning, the population will be 600 times e to the power of 0.1144 times 0. You just put 0 in for t. That gives e a power of 0, and anything to the power of 0 is 1, and 1 times 600 is 600. Therefore, the population is simply 600. Okay. Part 2. What will the size of the population at time, what will be the size of the population at time t equals 10? So at t equals 10, and again we go back to the same formula. P equals 600 e to the 0.1144, and this time t has a value of 10. And you go to your calculator, very simple. You plug in 600, shift ln, which brings you to the e function, 0.1144 bracket 10, and press equals, and the answer comes up at 1883.58. Now, we told to round off to anything? No, that's fine. So 1883.58. And again, because it's got to do with the population of bacteria, you can't have a population of 0.58 bacteria. So therefore, we just say, which is roughly equal to 1884. Okay, just round it off to the nearest whole number when you're dealing with things that exist as whole items. And the last one then, number 3, involves find to the nearest minute the time at which the population will have grown to 6,000. Now, population to 6,000, that means p is equal to 6,000. So this time, I'm looking at p equals 6,000 with the same formula. So now I end up getting 6,000 equals 600 multiplied by e to the power of 0.1144 t. And my job in this equation is to get t on its own. Now you'll notice that t is a part of the exponent of e, so therefore e is going to have to be tackled at some stage, and the way in which we get rid of base e is to bring in a natural log on both sides. Okay, so the first thing I'm going to do here is I'm going to divide both sides by 600. So 6,000 divided by 600 is equal to e to the 0.1144 t. Okay, now what I'm going to do next is I'm going to get the natural log of both sides so I can get rid of this e. Don't forget, the natural log and the exponential function are inverse functions of one another, and when they're used together they cancel one another. So the natural log of both sides, that's 6,000 over 600. Now you're probably wondering, why don't I just divide the 6,000 by the 600? Leave the calculations till the end. Manipulate first, calculate later. Equals natural log of e to the 0.1144 t. And straight away, as we already know, the natural log and the exponent, they always cancel when they meet, and that leaves me with the natural log of 6,000 over 600 is equal to 0.1144 t. And all I've got to do now is divide both sides by 0.1144, and when I do that, that cancels with that, leaves you with t, and then your calculator will do the calculations for you. So just get into that habit. Manipulate, don't calculate, manipulate until the end. Okay, manipulate, get right down to the end, and then do your calculations. So on the top fraction, we've got the natural log, so fraction. So the natural log of 6,000 over 600, so 6,000 over 600, which is 10, but just put it in anyway as it is, all over 0.1144. And the answer there comes out as 20.13. Now, does it ask for anything? Yeah, find to the nearest minute. So we're given a condition on our question. Find to the nearest minute. That means that the answer we're looking for is the 20th minute. So 20 minutes. That's it. Okay, so that's question 1. Very straightforward. Question 2. a population growth of a certain city is modeled by the equation. Now you'll notice when we're dealing with growth, we're always dealing with exponential functions, because the exponential function is the mathematical model of growth, whether it be bacteria or humans or anything else like that. So we're told this time that we've got P equals 136,000 multiplied by e to the power of 0.006t. So a very similar formula to what we had previous. Part 1. What is the current population of the city? Now, what is the current? So current means now. Current means we're beginning now, okay? So therefore, if you're taking now as a mathematical reality, now is the beginning. And the beginning is always t equals 0. See that? That's always the beginning. So if you're starting to count now, if you're using the current population to be now, then t is going to be equal to 0. And that means we end up getting 136,000 e to the power of 0.006 multiplied by 0. And again, these multiply to 0, which gives e the power of 0, which becomes 1. And 1 times that is 136,000. So that's the current population now. Now is always t equals 0. Okay, part 2. What will the population of the city be in 5 years' time? Okay, so what will the population? So now we're looking for the value of p at t equals 5. So that means I use the same formula. P equals 136,000 e to the 0.006 t5. Because don't forget we're dealing with 5 years hence. So we just get the calculator to work that out for us. That gives me a value of p of 136,000, 136,000 e to the power of 0.006 multiplied by 5. And the answer there comes out as 140,141.82. And that's the population in 5 years' time. Now again, because we're dealing with humans, you can and you're allowed to go to the nearest whole number of 140,142. And then part 3, after how many years? So this time they're looking for the value of t, but what are they giving me? They're telling me what the population is. So in part 3, we're being asked about t at p equals 153,000. So use the same formula again. P is equal to 136,000 e to the 0.006t. And now we're being asked after how many years. So now we're being asked to work out t at p equals 153,000. So we put that 153,000 over here for p. 153,000 equals 136,000 e to the 0.006t. And again, remember, if the exponential function is being used, the natural log is going to be pulled in at some stage in order to remove the exponential base to get to the power of t, to get t on its own. Okay, so the first thing I'm going to do here is I'm going to divide both sides by 136,000. So 153,000 over 136,000 will give me e to the 0.006t. Now I want to get rid of e, so I'm going to bring in the natural log on both sides. 153 over 136. Now don't forget, look, you can knock off the zeros when you're dividing. If there's the same number of zeros on top and the bottom, knock them off. So the natural log of 153 over 136 is equal to the natural log of e to 0.06t. And again, as we said already, when the natural log and the exponent base are together being used in the same part, they will cancel one another and leave you just with the power to operate with. So now I'm going to divide across by 0.006. So the natural log of 153 over 136 divided by 0.006 is equal to t. And manipulate, see that? I manipulated, didn't do any calculations until now. So turn on my fraction, put in my natural log, and then another fraction immediately after that, 153 over 136. And it's great that we can build these up on the screen. Build them up on the screen exactly the same way she's written them down. And that comes out as 19.63 years. Okay, now again, is there any conditions on that? After how many years will the city's population be 153,000? No, leave it, 19.63 years. So again, very straightforward question. They'll always give you everything you need except the variable you're asked to find. Just keep that in mind. If they ask you after how many years, that means they're asking to find t, so they have to give you everything else. If they're asking you how long will it take and you're asked to find t, they'll give you everything else, okay? So just be careful with the questions like that you understand what they're giving you in order to deal with the question. Question 4. Scientists can estimate the age of fossils by measuring the amount of carbon-14 in the fossil. When an animate object dies, the amount of carbon-14 in the object is given by. Now, do you notice that the power is negative? So that means the quantity is going to drop, and that makes perfect sense. When an organic object dies, the amount of C14 begins to dwindle. Okay, that's why we've got a negative power. That'll bring the values downwards as the value of T increases. Where T is the number of years and M is a constant. Okay, show that M is the mass of carbon-14 in the object at death. Now go back. When an animate object dies, so in other words, we're waiting for the object to die. We don't count carbon-14 before death. We only start to count the amount of carbon-14 after death, which means that death is being taken as the start of the carbon-14 decay. So therefore death is T equals 0. So in part 1, we're going to take the formula. 1, 2, isn't it? 1, 2, T. Make sure I get that right. So, A equals ME minus 0.00012 T. And what are we told to use? At T equals 0, because we're being asked at death. And at death, T is equal to 0, because that's when we start counting how carbon-14 begins to drop. So at T equals 0, A equals ME to the minus 0.00012 times 0. The power becomes 0. The base to the 0 becomes 1. 1 times M is M, and A equals M. So what does it say? Show that M is the mass. There you go. A equals M. Now that's going to be important as an identity if we need to interchange A for M or M for A. Okay, say we end up with an equation in 2 variables, A and M. Well, then all we've got to do is go back to this reality here that allows me to realize that A and M happen to be interchangeable, and then we can change the A for M, get the equation in 1 variable, and work ahead if needs be. Let's do part 2. An object is 3,000 years old, so T equals 3,000. Find in terms of M the mass of carbon-14. Okay, so let's write down the formula again. ME minus 0.00012 T. So that means at T equals 3,000, I'm going to put 3,000 in here. So A is equal to M times E to the minus 0.00012 times 3,000, because it gives me 3,000 years. And again, all I've got to do, because it tells me in terms of M, see that? So in other words, leave M in your answer. M has to be in your answer. So all we can do is go to the calculator, turn on the exponential function, which is the second function over the natural log, or shift natural log, minus 0.00012 times 3,000. And that comes out as 0.6977, just to round it off to 4 decimal places. Okay, and the last part, part 3. If an object now contains half the carbon-14 that it contained at death, so in other words, A equals a half, okay, because we're dealing with a half of the mass. So if an object now contains half the carbon-14, now let's think about this. A equals a half of what? A equals a half of the original mass of carbon-14. See? It says here, the mass of carbon-14. So M is the mass, so therefore A and M are interchangeable. So if you want half the amount, you're going to have half the mass. So in other words, again, I'm going back to this formula here in case I need it. If an object now contains half the carbon-14 that it contained at death, so half the amount can be interchangeable with half M. Let's see what happens. How old is the object? Okay, well A, and how old is the object means you're going to want to find T. Okay, A equals M E to the minus 0.00012 T. Now, in part 3, my job is to work out the value of T. And because T is a variable in a power, I'm going to have to get rid of the base at some stage. The base is E, therefore the only thing I will be using later on to get rid of E will simply be what? The natural log. So the natural log is going to come in. Okay, now be careful. we want half the amount. Okay, now just check that. It says if an object now contains half the carbon-14. So I want half the amount of carbon-14 equals Me minus 0.00012 T. Now we've got a problem. We've got 3 variables. I can't solve this with 3 variables. I can't even solve it with 2. I can only solve it with 1. Is there any way that I can interchange a half the amount in order to match either of these 2 variables here? And the answer is yes. Because of the fact that A is equal to M from part 1, then it also finds that a half the amount can be represented by half the mass. So I'm going to instead write down here half the mass is equal to the mass e to the minus 0.00012 T. The m's will cancel, and that will leave you with a half equals e to the minus 0.00012 T. And now notice, all I've got left is T, but it happens to be trapped in a power. So I've got to get rid of the base that it is a power 2, and that means I want to get rid of e, so I'm going to bring in the natural log on both sides. Okay, and again, as we said already, when the natural log and the exponent work together, they're inverse functions of one another, so therefore they will cancel one another, and I'm left with the natural log of a half being equal to minus 0.00012 T. So I'm going to divide both sides by minus 0.00012, and let's see what happens. That cancels with that, and then that leaves you with T is equal to. So you go to your calculator again, turn on your fraction, put in the natural log of 0.5, and underneath that put in your minus 0.00012, and the answer comes out as 5,776.23 years. Now again, is there any conditions? Does it say anything about if an object now contains half the carbon-14 that contained at death, how old is the object? No, that's fine. 5,776.23. Not asked to round off. That's perfectly fine. Okay, and the last one, question 6. pH is a measure of the acidity or basicity of a solution. Solutions with a pH less than 7 are said to be acidic. So if there's a pH of less than 7, it's equal to an acid. And solutions with a pH greater than 7 are said to be basic. Okay. A solution with a pH equal to 7 is said to be neutral. You know this from your junior cert already. Okay, chemists define pH by the formula. Here we go. Here's your formula. pH equals minus log. Now I think that's not 10 times that. I think that's a misprint. I think that's supposed to be minus log to the base 10. And the only reason I know that is because I use it in chemistry. We actually say that the pH is minus log of the hydrogen ion concentration. Okay, minus the common log. So that should be base 10 of the hydrogen ion concentration. So there's a misprint there straight away. Hope you got that. Hope you realize that. Okay, part 1. A substance has a hydrogen ion concentration of that. Determine the pH. So determine the pH. pH equals minus log to the base 10 of the hydrogen ion concentration, 1.5 by 10 to the minus 5. Well, guess who can handle that? Your calculator. Now you're using just the log button, log, not ln, just the log, which is beside the ln. So minus log of 1.5 by 10 to the power of minus 5, and that comes out as 4.82. And what does it say then? Determine the pH done and classify the substance as an acid or a base. Well, it's less than 7, so therefore it's acidic. That's part 1. Okay. Part 2. What's it asking? A substance has a hydrogen ion concentration of 1.4 by 10 to the 9 moles per litre. So you're asking you to do the same thing again. Minus log to the base 10, this time of 1.4 by 10 to the minus 9. Okay, so do the same thing. Let's just change that minus 5 for a minus 9. And let's go to change to 1.5 for a 1.4. So minus log to the base 10 of 1.4 by 10 to the power of minus 9. And that pH comes out as being 8.85, which is greater than 7, so it's basic. Okay. And finally, if a solution has a pH of 8, so at pH equals 8, right? We know that, 8.2. What are we being asked to use? We're being asked to use pH equals minus log to the base 10 of the hydrogen ion concentration. That's the formula. So at pH 8.2, find the hydrogen ion concentration. So I want to work out the value this time of H+. So I'm going to put 8.2 in here under pH minus the log to the base 10 of the hydrogen ion concentration that I'm now being asked to find. Okay, first things first. We're going to move in towards this unknown H+. So let's multiply across by -1. Let's move the minus over the other side. So minus 8.2 equals log to the base 10 of the hydrogen ion concentration. Now, how do I get rid of a log that I don't want? Right, just keep this in mind, because we've been dealing with the exponential and the logarithmic, the natural log functions in the previous 2 questions or 3 questions. How do I get rid of log to the base 10? To get rid of a log, I have to bring in a base on both sides that matches the base of the log. So this time what I'm going to do is I'm going to bring in base 10 on that side and base 10 on this side. And when you have base 10 raised to the power of log to the base 10, guess what? They cancel. So what do you end up with? 10 to the power of minus 8.2 is equal to the hydrogen ion concentration. And that's it. Doesn't ask you for, give your answer in the form of a by 10 to the n, where a is an element of natural numbers and n is an element of z. So all you've got to say is it's 1 by 10 to the power of minus 8.2 is equal to the hydrogen ion concentration. Now, that's the question I asked you to take a look for homework. They're not going to get more difficult than that in terms of the test we're going to have on Thursday. So what I do want you to make sure you understand is that you will be examined on indices and their rules, logarithms and their rules, okay? And particularly dealing with the equations that involve substitution. So where you have a common term in the first 2 parts of your equation and you've got to take it out and let y stand in. Those type of things. Practice those well. And finally, there will be a question or 2 very similar to what we've done today. The questions that are based on real life situations involving logs or involving exponents, which eventually you'll have to cancel by bringing in either the natural log if you want to get rid of an exponent, or a base if you want to get rid of a log to any other base. So if you wanted to get rid of log to the base 5, you'd bring in base 5 on both sides. If you want to get rid of log to the base 21, you'd bring in base 21 on both sides. If you want to get rid of the exponential function, you bring in the natural log on both sides. Okay, so that's what we've got to remember in terms of questions like that. So what I'm going to let you do now, I'm going to sign off. We're finished once you've gone through those questions yourself, but you're going to spend between now and Thursday's test, please, revising logs, indices, and then practical problems involving logs and indices. But in the meantime, if you are revising and there's anything in this session that you don't understand or you want me to go over it again, please throw the question my way and I'll get you back a solution.